Hello guys, so welcome back. So let's move on to our third part of the lecture. Now, okay, the topic I will tell you later about the topic. Let's leave the topic for now. So let me tell you about one of my friends. Okay, so I have a friend named Sachin. No, not Sachin Tendulkar. He's too old to become my friend. This guy is Sachin Kungulu. Yes, Kungulu. So as you can see, he's also a teacher, but he's a physics teacher. So one day when Kumulu was teaching in the class, he was teaching, Newton's laws of motion and all, and so he suddenly he wanted to know how many of his students really liked physics. So what he did was, um, he, he asked, he asked how now students which are their favorite subjects, and one person started saying that, the other person started saying the next one other subject, and the whole class was in a commotion. So then he said, okay, guys, stop. Instead of you all saying, I will ask you. So he started asking very systematically. Students, how many of you vote for physics? So then there are 8 people raised their hands, and he noted it down. Then he said, okay, how many for chemistry now? Then 7 people raised their hands. Then he was like, not bad. How many for math? Not surprising. Only 5 students. Okay, wait. If I keep on saying like this, you won't get it right. Okay, let me note it down. 8 students voted for physics. Then when he asked for chemistry, 7 students voted for chemistry. And when he asked for math, 5 students voted for math. Now, there were 2 students who voted for no favorites. They were highly diplomatic students. They said that all subjects are equal, sir, in front of our eyes. We do not vote for any subject. We consider all subjects as the same. So, they were the no favorites student. So they voted for no favorites. Now I'll tell you something because you all are my students. I'll tell you one more thing. There are only 16 students in the class. Okay. Now, someday if you meet Kungulu, don't tell him that I told you all these things. Okay. Now, so what do we have here? We know that 8 students voted for physics, 7 for chem, 5 for math, and 2 diplomatic people. Now, what I want to do here is, I want to, draw circles. Yes. No, don't worry. This is not a drawing class, but I want to draw some circles now. So I will draw a circle for physics. I will draw a circle for chemistry, and I will draw a circle for math. Okay. So before drawing a circle, first let me draw my playground. That looks nice. Then okay, my first circle, a larger circle for physics, little smaller circle for chemistry, a very small circle for math. Now let me name them. Physics, 8 students. Chemistry, 7 students. And math, 5 students. That looks cool. Oh, we forgot our diplomatic students. Where are they? I'll put them here. Okay, I'm not putting them in a circle. You know why? Because see, everyone who voted for chemistry, I put them here. Everyone who voted for math, I put them inside this circle. For physics people, I put them inside this circle. So whatever comes outside these circles are people who didn't vote for physics, chemistry or math. Right? So those people I can put it outside. Because the same thing, right? If I put a circle, then what will be outside? No one will be there on the outside, right? So whoever didn't vote for physics, chem and math, I'm just putting them outside the circle. This white space is what is outside the circles. So this is n represents no favorites, 2 students. Now let me note down the important thing. There are only 16 students in the class. Now guys, look at this. With the data I gave and with the number of students in the class, total number of students in the class, don't you feel something is awkward? look carefully. 8 plus 7 plus 5 plus 2 is 22. See, 8 plus 7 plus 5 plus 2 is 22. 22 students. But how can it be? There are only 16 students in the class. Any idea? Think about it. So what we can conclude from this is there might be people who raised their hands for more than one subject. For example, there might be one person who voted for both physics and sir. When Kongulu sir asked who would liked physics, one guy raised his hand. The same guy raised his hand for chemistry also. Probably, I'm thinking. So I'm also thinking like you. So maybe that's what happened. That's the only way this count can be 22, because there are only 16 students in the class, right? So I think this way of representing them is not that good. Let me look for another way of representing them. This looks better. Now according to this, I have put this blue circle for physics, yellow circle for chemistry, and yellowish green. I know, I'm not getting too technical here. Yellowish green circle for chemistry, the pinkish red circle for math. Now look at it. Do you see that there is some common area between these two? See, there is a part where the yellow circle and the blue circle meets. See this part? This part. Do you see this part? Yes. Here the red circle on the here this part all the circles meet. See, this part all the circles meet this part, and here physics and math meets. See, physics and math meets here. Physics, chemistry and math meets here. This small area, this area like this. Physics, chemistry and math meets here. And then here we see physics and chemistry meeting. Right. So what do we understand here? There are students who voted for physics and chemistry. There are some people who voted for all the three subjects. There are some people who voted only for physics and math. Right. So look at this now. So there are, as per this diagram, there are 4 students who only comes in the blue circle. See, there are 4. This number 4 only comes in the blue circle, right? So that means these 4 people only vote for physics. These 3 people only voted for chemistry. These 2 people only voted for math. Now I see one here. What is this one? This is the combined part of math and chemistry, right? So that means this one student voted for both chemistry and math. So he comes in the number of chemistry and he comes in the number for math also. You understand? Now look at this one student. So what he did was he voted for all 3 subjects. See, he comes in the common area of physics, chemistry and math. He voted for all 3. So that's why he also comes in the number for both of all of them. So that is one. And look at these here. Here 2 people are there. What did these 2 people do? These 2 people voted for physics and chemistry. Nice. See, they come in both these circles. And then we have this one person again. He voted for both physics and math. No wonder this issue comes. See, now you see there are people who voted for more than one subject. Now let us count all of them. 4 plus 2 plus 1 plus 1. This all comes in physics, blue circle, right? 4 plus 2 plus 4 plus 2, 6 plus 1, 7 plus 1, 8. 8 students for physics, right? Okay, let's count this one. 3, 1, 1, 3 plus 1 4 plus 1 5 plus 2 7. Yes, 7 students for chemistry. Right, that is also right. Math 2 1 1 1. 2 plus 1 plus 1 plus 1, 2 plus 1 3 plus 1 4 plus 1 5. Yes, 5 students for math. Now do you see how, even though there are only 16 students, now do you see how they came? Now let us count. If we have a doubt, let us count the number of students. 4 plus 2 6 7 8 9 10 11 12. Sorry, 9 10 11 12 13 14 15 16. See, count again. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So totally 16 students. See, excuse my handwriting. Okay, so there are totally 16 students. Now there is no issue, because we understood that there are some circles that are overlapping. Now, why did I draw these circles? To teach you how to draw circles? No, that was not my job. That your geometry, that was the job of your geometry teacher. Now, why I drew all these circles was to show you, to show you something. Now let us go back to our topic. So I didn't tell you the name of the topic yet, right? So name of today's topic will be Venn diagrams. Yes, Venn diagrams. So what are these Venn diagrams? Venn diagram is exactly what you saw in the previous thing. What you saw in the previous thing was exactly with all those circles in that playground, right? Those are called Venn diagrams. Now let me show you one easier example. There are 14 girls in a class. Okay, 14 girls in a class. 12 students like to play cricket in the same class. Okay, there are 14 girls in a class. In that class, 12 students like to play cricket. 5 girls like to play cricket. These are the only data that we have. 14 girls are in the class. Okay, 12 students like to play cricket. And out of that 12 students, 5 girls like to play cricket. Now let us draw circles for them also. So I draw a circle for cricket and I drew a circle for chemistry. Now we don't know how many students are there totally in the class. We don't know that. What we know is 12 students like to play cricket, 14 girls are in a class. We don't know how many boys. 5 girls like to play cricket. We only know that much. No. So this is our diagram. This is our Venn diagram. So I drew a circle for cricket, I drew a circle for girls, and then I put the number 7 people. So we saw that 12 people play cricket and 14 girls are there in the class, right? So I put the number. Okay, I can't put 14 here. Why? Because there are 5 girls who play cricket and at the same time they are girls. So I put the 5 here. They come in both the circles. So 14 minus, totally there are 14 girls. 14 minus 5 is 9. So these 9 girls do not play cricket. These 9 girls do not play cricket. See? And these 7 people play cricket, but they are not girls. So what are they? So these 7 people are boys. We do not know that here, but let us look. This is not given directly in the data, but we can guess from that. 12 minus 5. 12 students like to play cricket. 5 of them are girls. So what are the rest? 7. 7 boys like to play cricket. Now let us go back to the diagram again. So now by drawing this diagram we have come to know many things like this. Now there are people who do not like to play cricket also. These are the girls who do not like to play cricket, right? These are the girls who do not like to play cricket in this part of the circle. See, in this part of the circle you see girls who do not like to play cricket, but there are boys also do not like to play cricket. What about them? Them I can put it here. These are the boys who do not like to play cricket. They do not come in any of the circles. See, I cannot put them in cricket because they don't like cricket. I cannot put them in girls because they are not girls, obviously. So I am putting them outside. This is how Venn diagram works. I mean, I hope you're getting an idea of what this system is. Now, why am I talking about all the circles and Venn diagrams? How is it related to our subject? Let us come to see that. So, 14 girls in a class. I am making this my first set. I am making this a set. This is a set of 14 girls in the class. Okay. The set of girls in one class. And I name that set A. Okay. Then I am making another set. The set of the people who like to play cricket. I am calling that set B. Now I have two sets. So what is Venn diagram? Venn diagram is making a circle for each set and representing them in a playground. And what is a playground? Basically a rectangle. So in a rectangle, I am putting some circles and then I am showing you what is the relationship between each of these circles. See, because I overlapped these circles, now you know that there is some relationship between these circles. That is, there is a place where the circles overlap. What does that mean? There are girls who play cricket. Now, what does this portion mean? There are people who are not girls. There are people who are boys who play cricket. What does this part means? There are people who neither play cricket nor are girls. That means they are boys who do not like to play cricket. So this is the idea of Venn diagrams. This is created by, not created exactly. This is popularized by a person named John Venn. That is why it is called Venn diagram. Now, this overlapping part. So what is this? This circle is interacting with this circle, right? This is the portion of interaction with. This is the portion of interaction of this circle and this circle. So this portion of interaction is called intersection. Guys, remember this term is a very important term which we will be using consistently in this chapter. Intersection. Look at the term itself. Intersection is the area of interaction between two sets, or in the terms of Venn diagram, two circles. Okay. Now, look at this rectangle. You see this rectangle? Look at this rectangle. This rectangle contains everything, right? This rectangle contains people who play cricket. This rectangle contains girls. This rectangle contains boys who do not like to play cricket. This rectangle contains basically the whole class, right? The whole class is put inside this rectangle. So what is this rectangle called? What is the higher set from which we can derive all sets? From which all sets come from. What is the highest set? The higher set is called universal set. Remember what we learned in the last class and the class before that. The higher set, the set of consisting of all these small sets, is called universal set. Yes, this rectangle is universal set, and this, not this white space. Remember, it is not this white space. This universal set is the whole rectangle. The white space is boys who do not like to play cricket. Okay, universal set is the whole rectangle. Universal set is this rectangle. This rectangle is universal set. Now this interaction area is called intersection. Now I don't want to tell you more on these topics. This is enough for today. So I want you to know what are Venn diagrams. I want you to study how to draw Venn diagrams, how to represent Venn diagrams. So I'll be giving some questions to make you thorough in this topic. I'll be giving you some questions as assignment. Go through them, do them, submit them on time, and the next class, God willing, we will see what all things we can do with this Venn diagrams. Okay, so let's this will be it for today. So see you guys in the next class.